Excellent. So, welcome to this workshop. We are starting slightly late, so let's see a bit how we do the program, how it will go. Let me actually open the timer. Because now, we actually only have half an hour, which is 2/3 of the time that's stood for the workshop. But that's okay, because I mean, one of the most important things is just to meet each other and talk about stuff. So, okay, so this is about transitioning to open source software. I'll explain a bit about what that is and why you want it. We'll start actually exactly with what it is and why you want it. Then I'll briefly present a list with some alternatives, which can be useful also as a reference work to figure out what to switch for. You can also try to memorize them, then I'll test you during the drinks later. And then some considerations that you should have when you think about switching software. Then finally, there is a workshop bit, at least that was intended. I think we might actually go into the Q&A because I'm not sure whether now we have the time for the workshop bit, but that's fine because it was mostly meant to create some issues to then discuss with all of us. So, okay, so open science has many phases. One of the phases is citizen science, which has another session right now. One of the phases is open education, and there was a session on integrating open science in teaching earlier as well. One of the things that is quite known is open access publishing, so that your articles are accessible by everybody. And open data, so that data are accessible by everybody. Something that is slightly less known is open materials, which means that all the questionnaires, all the materials, everything everybody needs to replicate your study and your analysis are also openly available. And something that is even less well known is open infrastructure, which basically means the stuff we use to do all those things. And the stuff we use to do things should also ideally be open. And the stuff we use to do things usually boils down to IT nowadays. There's also open hardware, so open source EEG material and stuff. But I know nothing about this, so I will not tell you anything about it. But it exists. The idea of open infrastructure is that it's open source. I'll go into that in a second. Actually, I'll go into all of these in a second. That it's community owned, that it uses open standard, but not necessarily that it doesn't cost you anything. And then I mean money, not necessarily your soul, but money. Although it could cost you your soul if you don't do it right. It's always when I tell people it's not free that some people thought I have to leave. Yeah, it's okay. It's completely fine. Does it? Okay, so open source. Open source is the term that is usually used for what we often... it's okay. Oh, you have 2 bags. I was like...
Yes. Apologies for the interruption.
No, it's fine. The nice thing about these communities is that it's informal. You can dress however you want. And it's fine if people walk away when stuff is not free. So, what we mean when we talk about open source software is actually, or what we mean is usually what is actually called free software. And this free software has 4 freedoms, which for some reason start numbering at 0, which is probably a programmer joke because indexing in a lot of programming languages starts at 0. Not in R, it starts at 1, but many programming languages start at 0. First programming lesson, pay attention. So the first freedom is the freedom to run the program however you want. This is pretty similar to, actually all of them are pretty similar, to the freedoms you have if you decide to buy a hammer. You can use it however you want. Well, I mean, there are laws, so you can't exactly use it however you want, but within the laws of your country, you can use it however you want. Then you can study how it works and then change it so it works the way you want it to work. That's also true for hammers, for example. In fact, at Hornbach, for example, like a big do-it-yourself shop, they actually have separate stelen and heads of the hammers, kind of, so you can even compose your own hammers. This is something that's very normal for pretty much everything you buy. And according to people who believe that software should be free, it should also be normal for software. Then, the freedom to redistribute copies, so basically to help your neighbor, as it was originally phrased, help others. and the freedom to also pass on the versions you improved of your hammer. So if you have a hammer and you decide that maybe it should be sharper, and you make it sharper, to then give it to your neighbor who is in a fight with somebody else or something like that. So these are the 4 freedoms, and if you have those 4 freedoms for a piece of software, it's called free software. And that's usually what we refer to when we talk about open source software. The freedom to study how the program works, of course, requires that you have access to the source code, to the programming code that was then, as they call it, compiled into the program you run. If you want to distribute versions of your modified version, of course, you also need access to the source code. So this is open source. Community owned basically means that it is owned by the community. So it is not owned by a government or an industry organization. And that there are a number of reasons why this is important in science and therefore open science. First, we have very different aims. Companies, industry, has as an aim, generally, to make money, to create a profit. Especially if they have shareholders, then that is literally actually usually what the CEO's job is, to optimize profit for the shareholders. We don't make money. We lose quite a lot of money. We create knowledge, which is arguably priceless, but unfortunately society doesn't quite treat it like that yet. So we have very different aims, and that means these aims, of course, inform your strategies as an organization. They inform the choices you make. Ours are ideally informed by epistemic aims, so knowledge aims. We want to optimize the knowledge we create. We want to learn how the world works so that we can make things better for ourselves and others. So that's what informs our choices. Of course, if you are a CEO and you were the committee that hired you for your company did a good job, then you do your job well, which means that generally you will choose profit over epistemic aims. So that's one reason why the infrastructure we use should be under our control, because then at least it is optimized for our work, creating knowledge. Second, industry doesn't have protection against hostile takeovers. I'll show 3 examples of this later. But basically, with industry partners, if you have a company and they create the package you use for analysis, and they get bought by another company, say IBM, to name a wild example, and then IBM at some point decided that another completely random software package like SPSS is no longer interesting to them, they might actually stop development, just keep it there, have some security updates, but that's it. Of course, for our field, science, where our work is cutting edge, therefore the methods we use are cutting edge, ideally, that is very problematic. It actually blocks our ability to achieve our epistemological aims. And finally, as became very clear with what everybody calls recent geopolitical developments, there's a lot to be said for sovereignty. Both as a government, you want to own your IT infrastructure. For example, the fact that almost all municipalities in the Netherlands use Microsoft Teams is deeply problematic. So there are people saying this, and other people in ministries and at provinces and at municipalities being very resistant because they know Microsoft Teams. But it is deeply problematic, of course, from the fact that this is what runs our country and it's controlled by another country that is not necessarily friendly towards us. The same goes, of course, for the stuff we use to create knowledge. LLMs are an excellent example. Not because I like dissing LLMs, for those who know me, but just because it fits very well. Large language models are trained deliberately and with specific aims in mind by companies. They then underpay people in certain African countries to do this training. And because those people get instructions as to how to train those models, that means that if a certain sovereign of a country, say a president, were to instruct those large companies that they have to train the fact that trans people exist out of those models and make the models deny that this is the case, then this will happen. Imagine that you have a qualitative data set and you want to use these to help you analyze it or write letters or do other things. That of course means that their idealistic choices, idealistic might not be the right term given our values here, but those idealistic choices imposed on the company by their president mean that we create bias in our results. This is of course undesirable. So that's another reason why we want to own our infrastructure, because we create knowledge, and that knowledge arguably is never neutral, but the degree to which it is not neutral should definitely not be determined by potentially hostile other governments. So this is why we want community-owned infrastructure. Twitter is one example that was bought by a certain person who completely imploded it. This can happen with Twitter. Actually, Twitter, Science Twitter, was a really fun place to be. I owe a lot to Science Twitter. Actually, the pre-registration form for systematic reviews that I co-created, we got that idea on Twitter. And we got directly in touch with the guy who runs the Open Science Framework, Brian Nosek, on Twitter, talked about it, got it moving. And so that did a lot of good things, useful things for science. And now it's been destroyed because we relied on a company to provide this. So now I'm on Mastodon. If you're not on Mastodon yet, come to Mastodon. Unity was a program, is still a program to create games that suddenly decided to retroactively charge game developers. This did not go over well in the community, of course. So these people went over to Godot, which is like the open source alternative. And SPSS, of course, run by IBM now. They had a default for a certain dimension reduction analysis called PCA. That was the default for dimension reduction, whereas the social sciences almost never can use that correctly. They have to use factor analysis, but that was not the default. So a lot of papers actually use the wrong analysis because they just had the wrong default, which is almost impossible to change if it's a huge company. Similarly, they only introduced CohenD in version 28 or something, even though when they had version 3 out or something, Cohen already published his book that it was really important in like 87. So when companies control our software, that directly impacts how we do our analyses and sometimes how we design our studies. So the way our software works has a direct influence on our epistemic endeavor, on how we create knowledge. So we want to own it. Finally, or almost finally, open standards. Open standards are the things that were, to put it very simply and incorrectly, but hopefully evocatively, the way we store stuff. If you have an atlas.ti file, that's a qualitative software package, and you have transcripts and you code them, you cannot open it with any other software but atlas.ti. There is a format in Atlas that you can export to if you make some effort, and that can be opened by others because that's an open format. There are some open formats in the world that we use to share things, but the SPSS file format, for example, which is used a lot for quantitative analyses in the social sciences, is not an open format. It's been like backwards engineered by people so that they can still open it, but it's not actually an open format. This is the order of the animations has some room for improvement. So plain text files, just simple text files, are probably the most open file format we have, right? Everybody can open it because it doesn't matter what you view it in. You can view it in a browser. You can even open it in Excel. It doesn't matter. You can read the contents. Comma separated values are almost as good. They're structured, so that's nice. They're more machine readable in that sense, but anybody can still open them. You can even, if they're small, read them without any dedicated software in Notepad, for example. HTML is another example. That's completely open. It's not very human readable, but it's completely open and the specifications are open. And actually right now, people are creating entirely new browsers from the ground up to read these because people are unhappy with existing browsers. There you go. ROC files is a recent format for qualitative data that was intended to be openable by everybody as well. So it's actually not a kind of file format that is often used by Word or by atlas.ti. Most file formats are, for example, zip files, compressed files. And if you would open them in a text editor, you would only see gibberish. But HTML, you do see the contents kind of. And CSV, you can open them in a text editor as well. This is an open format, open standard for qualitative coded data so that it's easier for everybody to share data regardless of what software other people have. They can just open it in a text editor or in Word. And that also makes it easier, of course, for other people to innovate. Okay, so without these openly available specifications, we also can never publish fair data. Because the I in fair doesn't stand for me, but it stands for interoperability. It's important that software, different software can connect connect, can open the data and kind of understand the function of different parts of the data. And that, of course, requires open standards so that the people creating the software know how to read the data and how to write the data. So if you ever want to publish fair data, you cannot do this with proprietary data formats. And therefore, mostly, you cannot do it with proprietary software. Okay. Oh, and this was the point I made earlier. For statistics, there are a number of software packages. SPSS used to be basically the only one that was used. But already in the 80s, maybe even earlier, you had R, which was mostly used by statisticians because it's more powerful, and you can easily code your own packages that are then part of the wider ecosystem. So the innovation happens there because the people who actually do the innovative work can work there. They can create their instrument there. This is true for any field, of course. You may recognize that like scientists in movies are actually never really scientists. They're never people sitting behind spreadsheets. They're generally kind of MacGyvers with technology. Their claim to like science to knowledge is because they understand how the technology works. They combine things, but that's generally the role that scientists have in movies. That's of course not entirely true because that's unfortunately never what we get to do. But we do get to do it a little bit. And that is whenever you actually innovate, whenever you try to do new stuff, that means you have to build stuff to be able to do new stuff. If you don't own your software, your infrastructure, you cannot do this. So that means you cannot innovate. So that means progress halts. You cannot do new stuff. So that's why we care. And it's not free, as in beer. You have free as in speech. Free software is free as in speech. But free as in beer, unfortunately, is not always the case. Because developing software costs time, and time is money. Hosting servers and more software is something that runs online, so you need a server somewhere. That costs also money and time. And of course, if you have software and people actually use it, you always have questions, and then you need somebody to pick up the phone and say, did you try turning it on and off? And that also costs money. In addition, especially if you have like larger packages like R, for example, there's a community, and they discuss what decisions should be taken. For example, for quantitative research, you always have random number generators that you use for simulation and lots of other things. There are many different algorithms that these RNGs, random number generators, can use. In R, they switched the algorithm at some point, which of course instantly made all the code created previously no longer reproducible. Even if you set a so-called seed, that you say this is the start number, normally you get the same sequence of random numbers that's created, but not anymore, because the default procedure was changed. That's of course a huge decision because reproducibility becomes more and more important. Those discussions take a lot of time with a lot of stakeholders, etc. So all this has to happen and that takes time. So institutions like, for example, universities, hogescholen, organizations working with pension funds, everybody using software infrastructure and sharing these aims, believing, for example, that the US should not be able to change the way our software works, should then decide to start paying for this open infrastructure. That's still a process we're kind of in. I mean, I notice when I talk to stakeholders at the Open University that it's already a hard sell to get them to change anything at all, then to change to open source. But then if they find out that it doesn't mean they save money, it's even worse. But this is a transition we're in, and this is a process we'll have to convince people of. So. Okay, so some practical reasons, because these reasons are all important for people who care about lofty goals, but there are also some actual practical reasons. Okay, the first one is maybe not very practical, but ideally we are inclusive to everybody, not only the rich people in the Netherlands and Germany and Belgium, but all the researchers. It is generally cheaper, of course, because when you develop open infrastructure, there are no shareholders. So you don't lose money to people who only get profit. There's also the principle public money, public code. We are generally, as organizations, funded by public money. And arguably, that should not then go into proprietary code that is then sold on. And of course, you want to control your software. That refers back to the first one. Last one is epistemological responsibility. That's kind of, as a researcher, your goal is to create knowledge. That's literally your job description. That also creates a responsibility to do this well. In the Netherlands, we have the Code of Conduct for Scientific Research, for integrity. And it has 5 principles, which I'll name in Dutch if it's okay, because I can translate them on the go. And I know the acronym in Dutch, which is ZOVET. Zelfstandig, onafhankelijk, verantwoordelijk, eerlijk en transparant. If you adhere to these, they pretty much already force you to use open infrastructure, because it's not very responsible, given everything we know about the dynamics governing closed infrastructure, to keep sticking to infrastructure. We have an epistemological responsibility if we want to create knowledge ethically and actually without bias that we know exists in, for example, LLMs governed by American companies, then we have to switch to open infra. And eventually, it's more sustainable. Because, of course, licenses become more and more expensive, and at some point, universities will stop paying for those. If you have open software, that dynamic might still somehow evolve, but it's much less likely, of course, because the goals of the communities, of the organizations are different. And you can change anytime, because open software uses open standards. So that means that everybody can use whichever software they like, because you can communicate with each other, because you have open standards for your data or for your other types of files.
You're not missing security?
Sorry?
Are you not missing security?
Oh.
That's one of the reasons.
Very good. Also a very good reason. Could you explain a bit about why that?
Well, the other option is closed software, so the source code is not shared. So that means not many people are actually checking the source code to see if there are any fundamental issues in there. So if it's open source code, which is really reviewed by many people around the globe, there's a higher likelihood that somebody somewhere figures out that there is some vulnerability in there. And also because the process of coming to a newer version goes a bit faster and it's not synced to a sales cycle, you probably also get a quick release if there's an issue.
Yeah, very good. Actually, I never realized this link to the sales cycle, so I'll try to remember that argument for future.
Well, at least for games, it seems to be that way.
Yeah.
But also for software, there are certain moments in the year when the bonuses are cut. So that's normally when they want to renew the licenses. Yeah.
Interesting. Thank you. Yeah, so security is also an important argument. This is just a list of software. There are other examples, of course. This list is also on the slide, and you'll see the QR code later again, so you can get it later if you want. And then you can also click the links, so that's more convenient. We also have it elsewhere. The bottom line is that there are alternatives to everything. But of course, switching to new software means that you have to learn new software. That's very hard if you are not like born behind a screen and you don't have anybody in your direct environment, direct proximity who can help you. So if you are considering switching, and for the rest you have good reasons, first look for training materials, because some things just are not so old, so mature yet, so there are not many training materials, and then if there's nobody around, then that might be harder. If you then do it with some colleagues simultaneously, of course it's much easier, because then you can just, book some time, it's fun, you can learn a bit, etc. And in theory, if you have like a community with multiple organizations in it, you could also approach other community members and then explore software together, or in the community ask whether anybody knows about it and then ask them to give a workshop or something. In addition, it's important because interoperability, that's great if you have open software and it has open standards, but of course if you can no longer access your previous files in a proprietary software package, that's a problem. So at least think that through and think about how you want to deal with that. And then finally, as I said, some applications are still young, so they're developed by a small team, and that makes them quite fragile. Like I referred earlier to this ROC standard, which is developed by me primarily and one other colleague. If we happen to be in a bus and it crashes, then the ROC standard is basically dead. We are almost finished our article describing the first version of the standard, and then it's open and anybody can take it. But of course, then you would need somebody else who happens to be interested in qualitative methodological innovation and be able to code and blah, 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 blah. So still then, even with the open standard, if you don't have a larger community working around it yet, it can be a good reason to not switch to that standard. Okay, so then we have the workshop bit, but I suggest that we just use it a bit because there might be some questions to just discuss those. So we skip this bit. And then thank you for attention, and I will deactivate the recording. And then if you have any questions, you can ask them.